Okay, so as we continue our study of functions defined by integrals, we're going to be using our second FDC a lot. Okay, so it says the function g of x is defined by the integral of f of t. Okay, so this is our graph that we have right here. So like we did before, I would like to start by finding the areas of the respective regions and just breaking it down. So this is a semicircle with, the area of a semicircle is pi over 2 r squared. Your radius is going to be 2. So 2 squared is 4. 4 divided by 2 is 2 pi. So it's going to be broken down into a pi and a pi. Okay? This is a triangle. So the base is 2. The height is 1. So this half the base times the height should come out to be a -1. Oops, sorry, -1. And then this is another triangle, 4 to 5. Its area should be 1/2. Okay. So as we go through these, it's important that you make sure that you write everything out. So part A. So g of 0. G of 0 is equal to the integral from 0 to 0 of f of t dt. So when I don't change the limits, it's 0. Okay? G of 3 is the integral from 0 to 3 of f of t dt. So the integral from 0 to 3 should be pi minus, it's half of this triangle right here, so pi minus 1/2. Okay? G of -2 is the integral from 0 to -2 of f of t dt. Okay, now when we're doing our integrals, the higher limit should be on the top. On the top. So I'm going to flip it and I'm going to change the sign. Okay, so we got to make sure that we work from left to right. So the integral from -2 to 0 is pi. I'm going to make it a -pi. Okay, and g of 5. So g of 5 is going to be the integral from 0 to 5 of f of t dt. So the area from 0 to 5 is going to be pi minus 1 plus 1/2, which is going to be pi minus 1/2. Okay? So for part B, it says that I want to find all values of x on the open interval such that you have a relative max. Okay, so we always have to consider our critical points. So our critical points occur at the zeros on the derivative graph. Okay, so we're going to have critical points at 2 and 4. So we're going to say that, so your critical points where x is equal to 2 and x is equal to 4. Okay, now since we're doing absolute max and min problems, we're going to, we're talking about relative max. Sorry, I read the next question, relative max. Okay, so we're going to have relative max at x is equal to 2 because the derivative is going from positive to negative. Okay, so that occurs where the original function f of x is equal to 0. So when I take the derivative of an integral, so when we're looking at derivatives, we said that critical points occur where the derivative is equal to 0. So if I take the derivative of this integral, I get the original function f of x. Okay, so we're looking where it goes from positive to negative. Part C, sorry, I jumped the gun. Find the absolute min between -2 and 5. Justify your answer. So when I find absolute maxes and mins, I have to consider the endpoints and I have to consider the critical points. So my endpoints, g of -2, g of 5, g of 2, and g of 4. So those are your candidates. So g of -2 we already found is a negative pi. G of 5 is going to be pi minus 1/2. G of 2, okay, so that's the area from 0 to 2, it should be pi. And G of 4 should be pi minus 1. Okay, so this is going to be your absolute max, and this is your absolute min. Remember, pi is about 3.14, so you can figure out which one is going to be relative to the other. Part D, write the equation of the tangent line at x is equal to 3. So g prime of 3 is equal to f of 3. That's how we get our slope. So f of 3 from our graph is a -1. And we need our y-coordinate. It's pi minus 1/2. Okay? So it's y minus pi minus 1/2. Your slope is a -1 times x minus 3. Part E, find the x-coordinate of each point of inflection on your graph. Okay? So points of inflection, we're going to deal with the second derivative. So g double prime of x is equal to f prime of x, because if I take the derivative of this function, I get f prime of x. Now, inflection points occur where the second derivative is equal to 0 and change sign. So if we remember what we talked about when we interpret the derivative graph, inflection points occur at the hills and the valleys. So we're going to have an inflection point at x is equal to 0 and x is equal to 3. Okay? So they occur at the hills and valleys. Now, last part, find the range. So the range is the difference between the absolute max and the absolute min. So your absolute max is pi, your absolute min is negative pi. So pi minus a negative pi is 2 pi. Now I know you're probably saying, yeah, this is going to be super confusing. You just have to work a lot of these problems, which we're going to be doing a lot of over the next couple weeks. So just stick with it and it'll work out. Okay, next example problem. I would like to say that this is kind of like an accumulation problem. Okay, or if we talk about like a, parking lot problem, or there's a monkey problem that we talk about in one of the free responses. So it says fish enter a lake at a rate modeled E of t, and fish leave the lake at a rate modeled by L of t. Both E of t and L of t are in fish per hour, in hours since midnight. Okay, so part A. It says how many fish enter the lake over a 5-hour period from 0 to 5. Give your answer to the nearest whole number of fish. Okay, so E of t is what enters, so we're going to set up an integral. We're given the rate up here, so if I want to find the amount of something entering, I integrate it. Now this is a calculator portion. So we're going to integrate in the calculator. So you're going to do, so I'm going to go ahead and put this in y1. I'm going to go and put the other one in y2. Okay, so I'm integrating y1. So we do math 9 bars y1 comma x comma 0 comma 5. and I get 153. So it says to round to the nearest fish. So 153 fish. Part B says, what is the average number of fish that leave the lake over the 5-hour period from 0 to 5? So key word here is going to be, sorry, I was reading the wrong, average. Keyword is average. So when we see average, we're going to do average value. So 1 over 5 minus 0, the integral of how many leave, so it's your L of t. Okay, dt. And we're going to put that in the calculator. So we're going to integrate math 9. Our L of t is in y2. We're going from 0 to 5, and then we're just going to divide that by 5. So it's going to be 6.06 fish. Make sure you actually go 3 decimal places on this. Okay, now it doesn't say go to the nearest whole number, so you need to make sure you watch your rounding. If you want to write the decimal out, then round to the nearest whole number after that, I suggest you do that. Part C. It says, at what time is the greatest number of fish in the lake? Justify your answer. Okay, so this is an absolute max and absolute min problem. So when we do absolute max and absolute min problems, we have to find our critical points first. Your critical points occur where the derivative is equal to 0. Okay, where our rate is equal to 0. Now, our E of t and L of t are both rates. They're both derivatives. Okay, so we're going to plug that into our calculator. Or we can find where they intersect in between 0 and 8, where they equal each other. So I'm going to change my window. So I'm going to change my window 0 to 8. Sorry, I was on it from another. Only zoom 6. Okay, there's our first function and then our second function, and we see that they're going to intersect somewhere. So let's change our y max to like 100. You can also put this in y1 and find your zeros, whatever's easier for you. That might actually be the better thing to do in this case. So we can do our intersect, calc intersect 5. And I'll show you how to do the other way too. So we can intersect, enter. So I get the time they intersect at is 6.2036. So that's going to be my critical point. Now, I can also put it in y1, 20 plus 15 sine of pi x over 6 minus, make sure you use parentheses, 4 plus 2 to the 0.1 x squared power, close parentheses. And if I want to find my zeros, I can find my zeros. Let me zoom 6. Okay, so if I zoom 6, so if I calc, I do my 0, and I'm going to go above and below. So I'm going to keep hitting the right arrow, keep going, keep going, keep going. It's going to come down, hit enter, above, below, hit enter again, and you get the same answer. Now, in order to find your absolute max and min problem, we have to consider our integral, because we're looking for an amount and we're given a rate. So if I integrate from 0 to 0 of E of t minus L of t, you'll get 0 because I'm not changing my limits. if I integrate from 0 to 6.2036 e of t minus L of t, don't forget dt. Okay, so if I integrate that in the calculator, I get math 9 vars y1 comma x comma 0 comma 6.2036, and I get 135.0149 fish. And I also have to consider at the end of the period, which is 8. Okay, so if I integrate math 9 vars y1 comma x comma 0 comma 8, I get 80.9199. So this is going to be your absolute min, and this would be your absolute max right here. Okay, and the last portion with the question part D. It says, is the rate of change in the number of fish in the lake increasing or decreasing at t is equal to 5? Okay, so as soon as I see the word increasing or decreasing, I'm taking a derivative. Okay, so the rate of change in the number of fish is given by e of t and L of t because those are your derivatives. So I'm going to take the derivative of e prime of 5 minus L prime of 5. So this is part D. Now, what I can tell from that is whether it's increasing or decreasing. Now, if it's positive, it's increasing. If it's negative, it's decreasing. So I'm going to do math 8 vars y1 comma x comma 5. And it's a negative 10.7227. So it's decreasing at t is equal to 5 because it's negative. Okay, so that's how we do an accumulation problem, and it goes back with this absolute max and absolute min stuff. Okay, so the key words for absolute max and min: greatest number of fish, least amount. Okay, so you need to make sure you pay attention to those. Okay, last question. Okay, so you got a function defined by an integral, and it says it's missing a portion of the graph. It only shows from -2 to 5. It says that you have a semicircle, a quarter circle, and you're given this point. So, like we did before, what you want to do is come up with your areas. Okay, so I know that this portion right here is going to be 1/2. This is going to be a -1/2. This comes out, that's half and 1. So it should be, so 1/2 times 1. So it should be -1/4. Okay. And this should be +1/4. This is a trapezoid. So the area of a trapezoid is going to be half the height times b1 plus b2. So this is 1 and this is 3. This whole area should come out to be 2. Now, here's the tricky portion. And you're going to have to probably go through this a little bit slower than I am right now for the sake of time. Okay, so this is a square, right? It's a 3x3 square. And this is a quarter circle. So area of a quarter circle is pi over 4 r squared. Your radius is going to be 3, 1, 2, 3. So it's 9 pi over 4. Now that's not this portion right here. Okay? So to get the portion out of the graph, you're going to have to subtract 9 minus 9 pi over 4. Okay? So, keeping in mind, whenever you're doing this, equal areas, if you have one above the x-axis, one below the x-axis, they're going to cancel each other out. Okay, so it'll make your life a little bit easier. Okay, so part A, it says that I want to evaluate the area from -2 to 6. Okay. Given that the area from -6 to 5, the missing region and this included is 7. Okay, so we're going to set up a nice integral expression. So I see that the -6 is on bottom, so I'm going to leave that right here. And then the 5 is going to have to cancel with something else. See, it's going to have to match going this way. Okay. Now, the integral from 5 to -6 is given as 7. So we didn't manipulate this. Now, the area from -2 to 5. Okay, so we're going to add all these together. This is going to cancel with this. This portion cancels with this portion. So we're left with 2 plus 9 is 11 minus 9 pi over 4. Okay, and you should get okay, so we should get 18 minus 9 pi over 4. Hold up, I wrote something flip. Why did I flip? Oh, sorry, I messed up. I wrote to flip. I worked these out earlier. So our bottom limit is higher than our top limit. So what we're going to end up having to do is make this negative. Okay, so when we flip it. So this should be 9 pi minus 4 when you distribute. Okay, so when we're looking at our limits, we're always working from left to right. Our bottom limit has to be higher. Our bottom limit has to be lower than our top limit. Sorry about that. This was confusing for me too. Okay. Part B, it says that we're going to evaluate the integral from 3 to 5 of 2f prime of x plus 4. So we worked a problem like this earlier. So we're going to split this up. Like that. Now, I want you to pay attention to this portion. So right here, the integral of f prime of x is equal to f of 5 minus f of 3 using your first FTC. The integral of this is 4x. We're going to plug in a 3 and a 5. Okay? So f of 5 is given to you as 3 in the original problem. F of 3 is given to you as 3 minus square root of 5. Okay, and then if I'm going to evaluate this integral, you get 20 minus 12, which is 8. Okay, now, so if we're gonna, do all the math with this, you can leave it like that, or you can distribute. So I'm going to distribute actually the 30s cancel. So you get -2 square roots of 5 plus 8. Now, it should be a positive, sorry. It should be a positive. 2 square roots of 5 because you have to distribute that negative out. Make sure you don't make that mistake like I just did. So your answer is 2 square roots of 5 plus 8. Part C, you're looking for an absolute max or an absolute min. So we're looking for the absolute max or absolute min from -2 to 5. So our first step that we're going to do is we're going to identify our critical points. So our critical points should be -1 and 1/2. So g of -1, g of 1/2. And then we're going to also consider our endpoints, g of -2 and g of 5. Okay, remember, we're going to be integrating this stuff. So g of -1 is the integral from -2 to -1 of f of x, or f of t dt, sorry. Don't skip this step, write it out. So the area from -2 to -1 is going to be 1/2. The area from -2 to 1/2 of f of t dt. Okay, so this section is going to cancel, so don't worry about that. So it should be a -1/4. G of -2, the integral from -2 to -2 of f of t dt is 0, because it doesn't change. And I'm going to go from -2 to 5 of f of t dt. And I already found that was, so it should be 11 minus 9 pi over 4. Okay, so this is going to be your absolute min, and this is going to be your absolute max. Okay, and part D. Okay, this is evaluate the limit. So I'm going to plug in a 1. If you see something that looks like this, a lot of times it's going to be L'Hopital's rule, but don't just skip to that. So we're going to plug in a 1. So 10 to the 1 power is 10 minus 3f prime of 1 all over f of 1 minus arctan of 1. Almost done. So f prime of 1 is going to be the slope at 1. Okay, so your slope of this line right here is 2. So your slope is going to be 2 up 2 over 1. So it's 10 minus 6 over f of 1 is 1. And arctangent of 1 is going to be pi over 4. Okay, so arctangent means you're asking yourself, at what angle does tangent equal to 1? Now understand this was a little bit longer lesson. These will get quicker as we do them. I thought this particular problem was kind of hard. But the homework questions should be a little bit easier, and we just have to keep grinding away at this. So if you have any questions, feel free to reach out, and have a good day.